It is time for our next video lesson, and this one is called The Measures of Central Tendency, and it is our video lesson number 24. For this lesson, of course, you need your TOC you were given in class, number 24, your pencil or pen to take notes, a highlighter, marker, colored pencil is always helpful, and this is still part of our calculator unit. Yay! Let's get started. Measures of central tendency. Numbers that are called measures of central tendency can be used to describe the center of data. And you don't really hear it called this much. What you know them as are mean, median, and mode. I know you're all like, oh, I know a song about this. Yay, you can sing it in class. All right, let's go through some quick definitions. The mean is the sum, adding, of numbers in a set of data divided by the number of items in the pieces of data. So you're adding all the numbers together and dividing it by how many numbers there are. The mean is also called the balance point. I want you to put a star around the word balance point because it's really important that you make a connection between mean and balance point, because when you see the word balance point, you're really just finding the mean. We also call the mean the average. And think of it this way. See this mean teacher? Her job is to average your grades. That's what all of your math teachers do. We add up all your grades, and then we divide by how many grades we have, and that's how we get your overall grade. That's why we love math so much. The mean teacher averages your grades. Ha ha ha, we're so funny. Look at this example. If you take John, Peter, Mark, Sam, and Vincent's ages, and we add all of them up together, and since there are 5 people there, we divide it by 5, we get a mean or average age of 23.6. The median is our second measure of central tendency. It is the middle number in a set of data when the data is arranged in ascending order. If you don't remember what ascending means, you might want to write this off to the side. It means least to greatest. Ascending means least to greatest. If the data has an even number of data pieces, then the median is the mean or average of the 2 middle numbers. So you're going to put all the numbers in order from least to greatest first, and then you're going to find the number in the middle. And I'll show you how to do that. So let's take that same piece of data, John, Peter, Mark, Sam, and Vincent. We're going to take all their ages and put them in order from least to greatest. Woo! Look how easy that was. Now we're going to cross them out, go from one side to the other, keep crossing out until I come to the one in the middle. That's the median. Not hard. Now, if there were 2 numbers in the middle, I would add them together and divide by 2 to find the median that's in the middle. So my median here was 26. The last one we're going to talk about, probably the easiest one, is the mode. And I like to remember mode because MO in mode stands for most often. And it is the number or items that appear most often in a set of data. I have here that you use when most of the items are or over 50% of the data is the same number. It's not always 50%, but it's the one that occurs the most. But sometimes you can have two different modes. And I'll show you some examples in just a second. You might want to write a little note here that the mode is the most popular. It's when you say what's the one that was voted for most, or what was the favorite ice cream, or what's the most popular shoe size. Those are the things that are going to be the mode when you're looking at measures of center. So look at the example on the left. The mode is the most frequent value. You count how many of each value appears. The mode is the value that appears the most. You can have more than one mode. However, you cannot have more than two. So if you look at this example, I have 2, 2, 3, 5, 5, 7, 8. Notice how easy it is to find the mode when they're in ascending order, means least to greatest. If I see that, I have 2 2s and 2 5s. Boom, I have two modes, a 2 and a 5. Those are my modes. If I look at my example on the right, the example number 1, all of them appear once. So since they all appear once, I don't have 5 modes, I have no modes. So I just say no mode. In example number 2, I have a whole jumbled mess, which is why it's easier if you put them in order from least to greatest. But if I went through, you can see I've already numbered them for you. I have 3 3s. So since I have 3 3s, that appears the most. That is my mode. All right, let's talk about something called an outlier. An outlier is a number that is outside part of the group. So most of our data is data that is pretty close together. So it's usually like in a certain range and it's close together. However, an outlier is something that's not close to that set of data. And the outlier is going to affect the mean, because the outlier is a number that is way too big or way too small. And I'll show you an example. If you look at this set of data, 20, 22, 1, 33, 27, 100, 28. So if you look at that set of data, 20, 22, 33, 27, and 28 are all in my 20s and 30s. They're all pretty similar. Say I was looking at ages of people in a restaurant. If I was looking at the ages of people in a restaurant, I would say, okay, they're all 20s and 30s. But then if I looked at that 1-year-old, whoa, and a 100-year-old, that 1-year-old and the 100-year-old, they're outliers. They're way too young and way too old to be in that restaurant. So if I added up all those ages, that 1-year-old and that 100-year-old are going to really affect the average or the mean of those ages, because they're going to make that average really different than the actual representation is. My actual average should be between 20 and 28, or sorry, 20 and 33, because those are the majority of the ages. But that 100 and that 1 are going to really mess up my average. So that's why the outliers really mess everything up. We call them the liars for that reason. So outliers are the liars. So watch out for those guys. So last year you were supposed to learn about when do I use these? When are they most useful? And you still need to use this, so we're going to go over just as a refresher. So if you have a highlighter, highlight these key things. The mean is most useful when the data has no outliers. So pretty much we use the mean all the time, unless there are outliers. If there's outliers, you're not going to use the mean. Remember, those outliers are the data that's way too big or way too small. The median we would use if the data has outliers. So use the mean most of the time, unless there's outliers, and then you use the median. And the median, you also have to watch out for big gaps, because if there's big gaps in the middle, then you don't want to use the median. The mode is when there's many identical numbers. And you also want to put a little note here that it's when you're looking at what's most popular. So what's the most popular ice cream flavor? What's the most popular vote? What's the most popular shoe size, age, things like that. When I say many, I mean more than 50% of the data. You're not going to really use the mode much for the measure of center unless you have a lot, like it's 1, 1, 1, 1, 1. So if you're looking at the age of 6th graders, then you would use the mode, because most of you are between the ages of 11 and 12, you know, so you would use the mode there. The range. Now, put a big, huge, or highlight this right here where it says not a measure of central tendency, because the range is not a measure of center. It tells you the range of the data, biggest minus smallest. It is the difference, subtraction, between the greatest and the smallest number. It is not a measure of center. It is not a measure of center. It is just telling you how big the range is, how from the biggest to the smallest. So it is not measures of center. So don't say mean, median, mode, or range. It's not measures of center. It says highest minus lowest. So if you need to write that down, you can. If you look at this example, it's 6 minus 3 because 6 is my highest, 3 is my lowest. So that tells me the range of my data is 3 numbers. But it wouldn't tell me my middle is 3. No. The last thing we need to study is balance point. And if you remember from earlier in the video, balance point is another name for the mean. And it is when the data is evenly distributed on a number line. And so if you look at this number line that I have here below, what we're going to be doing is taking X's or chips or something, and we're going to be manipulating them on a number line. So if I give you this number line like this, I'm going to say find the balance point. What I'm really saying is find the mean. Now, some of you are going to look at that and go, oh, well, I have 2 1s, I have a 3, I have a 4, I have 2 7s, I have a 9, I have 2 10s. You're going to pull those numbers off, you're going to add them up, you're going to divide by how many you have, and you're going to find the mean that way. That's fine. Others, you're going to want to do this. You're going to say, oh, here, I'm just going to move all these X's, and I'm going to find the balance point this way. Perfect. You can just keep moving them until you find your balance point. Now, I can't move my X's anymore because once I start moving them this way, I'm just going to keep trading them back and forth. So I look at this and I say, okay, my balance point will be between 5 and 6. But because the majority of my X's are on 6, I know that my balance point is going to be closer to 6. So I would say my balance point's probably going to be like in between 5.75 and 6. So, but you can do the actual math to find out what it is exactly. Now, there will be questions on your test and on your SOL and things where they're going to give you letters. So you need to know how to manipulate things on a number line and not just rely on the math. And now it's time to log in and show what you know, because that's it.